So again, welcome back, ladies and gentlemen. This is our final lesson for today on rational expressions called division of rational expressions. The only note you have to remember for division is, although you see over there still the factor, state restriction, and simplifying. The only new concept of division of rational expressions are, once you stated the restriction and factored everything, you basically multiply by the reciprocal. That's the only thing. And really, what that tends to lead, check for more restrictions. Now, I like going slowly so that it makes sense. After a while, some students tend to go faster or do a shortcut, but I don't recommend that, right? One more time, tend to take your time, go carefully. You should be all right. And it hopefully will show up in these two examples. Again, I'm not 100% sure. Because not always does it happen, right? Sometimes it does, sometimes it doesn't. That's why division is a little bit trickier than multiplication. Let's take a look at example 1 of example 3, of example A of example 3. And the question is, hopefully I copied it right, 2ab over 5c divided by 14a squared b squared over 15c squared. So the first rule is factor. But because these are all monomials, we're done, right? Pretty easy. The next step, state restrictions. Again, they're pretty easy. C here and c squared here, denominators. I think everyone agrees that's one of our restrictions, right? Now, one more time, this looks like a fraction, right? That's what the whole point of rational expressions are. They look like fractions. Division is really multiplication of the reciprocal. So let's just take our time and flip that. That's what the word reciprocal means. So the 15c squared is now in the numerator, and 14a squared b squared are the denominator. Now, before you start simplifying, check for more restrictions, if there are any. And I think everyone agrees now, Mr. Chen, the a and b, they're variables, they're unknown. There are other two, so a and b, and then equals 0. Let's pause here. Everyone okay? Any question about that? Notice, once we get the division out of the way, and really mean multiply by the reciprocal, it's just like multiplication, right? So let's just start dividing these out. This c, we'll do the coefficients first. You can do any order you want. But this 2 becomes a 1, this 14 becomes a 7. This 5 becomes a 1, this 15 becomes 3. Hope I'm not going too fast. This c divides out and changes this c squared to 1 of these. This a changes out this a squared to even 1. And this b, so what are we left with? 1 times 3, 3. 1 times 7, 7. C, A, B. And that's the simplified divided answer. Any questions, class? One more time, the hard part was, you see me written in orange, that's the reciprocal part. And a lot of you notice, I'm just, for teaching, don't get me wrong, you put them all on one side. A, B, and C can equal to 0, but just for teaching purposes, I just try to show you that was from the first step. And then, there were actually more restrictions. It says pause here, hopefully I can just check the video in case. I got it? Yeah, I got it. Whoops, didn't mean to make that shaky for those people at home. Any questions at all? Any questions on the class? So, for question B, it's a little harder, right? So we have 3x squared plus 7x plus 2 over x squared minus 6x divided by x squared plus 6x plus 8 over x squared minus 2x minus 24. Again, I recommend you go this slowly and carefully. So let's start factoring. Any volunteer want to help me out with the first one? That 3x squared plus 7x plus 2 looks scary. Small? Sure.
3x plus 2 and then x plus 3.
And x plus what?
3.
X plus 3. X plus 1?
Oh wait, yeah.
Because 2 times 1 has to be 2. And the denominator, did you factor that out? I think, well, let's double check that. Hold on, there's something wrong here.
Yeah,
Switch
sorry.
the
Yeah,
the
it's
ones.
1 and 2.
It's okay. Who cares? Who cares, ladies and gentlemen? Who cares? It's only math, right? No one cares. No one cares. You're probably not even watching this. Probably get 0 views, right? You're one of those lonely people. Thousands of videos. 4 views. Like this. That's okay, who cares? We can check work. It's all good. Denominator, different ones here? Denominator? Sam?
X bracket x minus 6.
Yeah, the way that you say it all the time, it's facetious. You don't have to say the bracket, right? X
Yeah.
bracket x minus 6. You just say x times x minus 6. Right? One more time. If you have a phone number, 416 555 1, 2, 3, 4. That's how you say it, right? I apologize, I'm old fashioned. I grew up when there were phones. There were phones, Mr. Chen? Yeah, you don't say bracket 416 bracket 555 minus 1, 2, 3, 4. No one does the minus of the brackets. Let's get some phone conversation. And by the way, if you want to call me, ladies on, that's how you reach. Okay. So anyway, let's state your emergency. I need help with that. Anyways, so then this one's fun. X squared plus x equals 8. Sorry, any different volunteer? Somebody new perhaps? Maybe? That hasn't said anything? Orhan maybe? Or Sam? Sure, take it away, man. Sure.
X plus 4, x plus 2.
X plus 4 times x plus 2, nicely done, that's correct. I think everyone agrees. And denominator x squared minus 2x minus 24. I think that's... Yep, Mackenzie?
X plus 4, x minus 6.
X plus 4, x minus 6, nicely done. Everyone okay with that? Any questions? Let's go this slowly, if that's alright. I like doing it slowly. The restrictions now. This x is 0, so that means 0. This one's 6. Negative 4. 6 is already written. So far so good, everyone okay? Any questions? Red rule, you see? Division means multiply by the reciprocal. I know it seems long. That's why you're in grade 11. Some of you find it tedious. We flip the second rational expression because division means to multiply by the reciprocal. So we have x plus 4 times x minus 6 over x plus 4 times x plus 2. But notice, not always check for more restrictions. So usually a lot of students realize, oh, look at these denominators. Well, this x plus 4, that's its negative 4, right? We're good. However, there was one more restriction. Negative 2. And some students say, but Mr. Chen, if you ever plugged in negative 2 into the original question, there's no problem. What are you talking about? And I said, I agree. But when you keep on working, that negative 2 is a problem. When you start dividing, because you can't have 0 in the denominator. And it will be in the denominator in this context, because that's what division is. That's the whole big idea. That's the hard part for a lot of you. And if some of you want to know what these restrictions are, and again, hopefully I'll have some time after we finish teaching on the math part, hopefully I'll explain it. Visually, really what they are, they're holes in the graph. They're holes in the polynomial. Before we continue, any questions? Hopefully, again, I'm not blocking anybody, or you can see that. So let's start dividing things out. Make this x plus 2, not x plus 2. This x plus 4, and this x plus 4. And this x minus 6, and this x minus 6. Holy cow. So what's our final answer? 3x plus 1 over x. With those 4 restrictions. Pause here for a second. Any questions at all? Melanie, you're good? Orhan, you good? No. And that, ladies and gentlemen, is division of rational expressions.